5 for solving problem of the day from GFG. Let's look at today's problem. Largest sum cycle. Given a maze with n cells, each cell may have multiple entry points, not more than one exit. You are given an array of n integers where array contains the cell number that can be reached from the cell I in one step. Age I is 1, that means I cell doesn't have an exit. The task is to find the largest sum of a cycle in the maze. Okay, so let's understand the problem with this example. Okay, so we have this example. So let's understand the question first. So I've given this array. Okay, 1, 2, 0, minus 1. So what does that represent actually? So this is 0th element, this is 1th element, this is 2nd element, this is 3rd element, right? So this array is meaning that 0 node is connected to 1 node, not node 1. Okay, this is node 0, this is node 1. Node 1 is connected to node 2. Okay, node 2 is connected to 0. Okay, node 3 has no connection. Okay, so it's minus 1, it is no connection. So actually we have given this graph. Okay, and here there is a cycle, right? So if suppose there is 2 cycles, then what we are gonna do is just calculate the node values. Okay, which is 0 plus 1 plus 2, which is 3 here. Now suppose there is another cycle like 3, 5, 4. Suppose in this graph we have another cycle like this, then their sum will be 3 plus 5 plus 4, which is 12, right? So you have to return the maximum sum which is possible from all the cycles. Maximum sum of from all the cycles. Okay, which is 12 here. 12 is the maximum of all sum that is possible from every possible cycles, which is 12. That is we have to return. But in our case, the example, we have only this cycle, so we have only one cycle, so we will return this value 3, right? The answer is 3. So that's the thing. So what we are gonna do is we'll just traverse the nodes one by one, and whenever we will get that the node connected to 2 is already visited, okay, we will visit one node and mark it by visited. Now at this time when we are visiting 2, we got that the adjacent of 2, the connected node of 2, which is 0, is already visited. So we got a cycle, right? Now what we will do, we got a cycle. Now we will backtrack and calculate the sum 0 plus 1 plus 2, and we will suppose our sum is 0 initially, so we will update the sum by the maximum of previous sum and this sum, so it is 3. As there is no other cycle, I will return this 3. If we had another cycles, we will compare the values of this sum and that sum from that cycle, and we will update the sum. So that's the thing, that's the intuition behind the problem. Let's now solve this. Okay, let's calculate a answer variable which is minus 1 initially, and we are going to call DFS. But before that, is visited and visited path. Okay, so if our this is visited, this is not visited, if our node is not visited, then we will call the DFS. Okay, and we will give here the edge and visited path. Okay, public, so it will be long, and not this, and this will be boolean. Okay, let's create the function int edge boolean visited. So initially we will do what? Okay, so we have to put here I think. So this is our current, right? So visited current equal to true. If edge of this current is not equal to 1 minus 1, so what we are gonna do, if visited we are gonna calculate the adjacent by edge of current, and if this is visited, not visited, if it is not visited, then we are gonna do something else. If the path is not visited, then we are going to do something else. Okay, now if it is not visited, just call otherwise Okay, so here if our path is visited, but so I will tell you everything. uh, let's just quote. So here we will update our answer by math.max of answer and our sum, and our function will be void and okay, so this function will be outside. Here we will just return the answer. Okay, now let's compile this. And let's do here false. Okay, so this will be visited path is true. Okay, yeah. So now let's run this. Let's submit this. Yeah, so we got it. Now let's dry run this thing to understand what's going on here. See, here, so we started from 0, right? So this is my current node. So I mark that by uh, visited, and visited path is also I mark true. Now I go to the adjacent of 0, which is 1, right? Now for 1 it is called. So I marked it visited, path visited true, and go to the adjacent of that, which is 2. So we marked it visited, marked it path visited true, right? We are calling the DFS, right? So we for each current node we are calculating the adjacent node. For 1 we calculate 2, which is a 1's adjacent node, and if it is not visited yet, 2 is not visited yet, call the DFS. So now when DFS is called, this is visited, this is marked as visited, right? And the visited path is become true for 2. Now for 2 we calculate the adjacent as 0, right? But 0 is visited here, right? So as 0 is visited, and my visited path of adjacent is also true, I mark this visited path as true. So what we are gonna do is we'll just sum up this cycle, right? So when I got an adjacent is equal to is visited already, that means we get a cycle. So this part is to just calculate the sum of this cycle. Okay, so we create a sum, we calculate the uh, adjacent, which is 0, and just keep adding all the adjacent of this 0 and adjacent of those adjacent. So for 0 we just add 0, and for 0 the adjacent is 1, we just calculating just the adjacent of 0 and so on, and adding them to our sum, right? So calculate 1, add to sum, we calculate adjacent. So adjacent is coming from the edge, so adjacent of 1 is the value at index 1, which is 2, right? So calculate 2 and add it to the sum. For 2, 2's adjacent is 0, right? But 0 is equal to my previous adjacent from where I was starting. So I use a do while loop here because I will start from here, checking the condition. If it is true, it is matching with itself, right? So that is why I'm using this do while loop, because I don't want to check this condition at first. Okay, because my current node is 0 initially, and I'm checking the condition that if my current node is 0 or not. 0 is my adjacent, okay, and my current node is adjacent, so obviously both of them are true. So that is why I'm using do while loop, because this condition will not be checked at initially. So after that I will calculate update the adjacent by 1, then 2, then 0. Now here they will verify the condition, which is true. So now this loop is terminated. So we calculate the sum as 3 and update the sum into my answer, and just mark false this visited path. Okay, so this is the basic algorithm. So that is how we are calculating the sum. Okay, the former thing is why I am using do while loop, because this is the case. I am starting from here. It is suppose m and n. N is my suppose adjacent, and this is suppose my current node m. So I am just updating my adjacent as adjacent of adjacent, which is now 0. Now suppose this node, then suppose this node, then suppose this node, then suppose this node. So at first both of them are same. After that adjacent is changing and keep changing until adjacent becomes this current node. So I don't want my adjacent to be checked with this current node. So that's why I'm using do while loop. And the second thing is this code is doing the sum part. So that's the thing. Okay, so I hope you understand the problem. If you don't, then just try run this thing on your own. You will understand definitely. So I hope you like the video. If you do, then do like, share and subscribe. See you in the next video.